So the electric field concerns only the potential difference between 2 points. Um, and previously what we could write is our electric potential, which is V of R is equal to minus the integral from A to B of E dot dl. Okay. And remember, the negative sign means that the electric field is pointing in the direction of decrease of V. So what we can do is we can set our reference point to infinity, and we can find the electric potential just due to a point charge. Recall that for a point charge, our infinitesimal displacement element vector dl is equal to dr r hat. So now we can write Vr as equal to minus 1 over 4 pi epsilon naught. Our integral, so our lower limit, is going to be from infinity to some point closer, which is going to be some point r. Q over r prime squared dr prime. And we have the prime in there because we're talking about the source charge, okay, so the source term. Now whenever you carry out this integral, we get rid of the negative sign because you're going to have integrating 1 over r squared would give us minus 1 over r. So what we find is our potential then is going to be equal to 1 over 4 pi epsilon naught by q over r prime, and that's between infinity and r. And what we see is that infinity, since we set the lower limit at infinity, essentially it kills off that part of the integral. So what we're left is our potential is going to be equal to 1 over 4 pi epsilon naught q over r. Now we can write this out more generally. If we consider our three axes, so we have our x or y and our z. So y, x, z. Our point charge is located some distance r prime from the origin. Okay, that's our source. And our field point is some distance r. Okay, the distance in between the two, between our charge and our point of observation, is r minus r prime. So now we can write a potential as V of r equal to 1 over 4 pi epsilon naught by q over r minus r prime. Now that's just for one point charge. Supposing that we have a collection of point charges, what would we do? Well, essentially we have the principle of superposition. We just have to add up the contribution from all of the individual point charges. And what we would have is V of r is equal to 1 over 4 pi epsilon naught by the sum from I is equal to 1, that's our first point charge, to some number n by q I over Ri minus r prime. Okay, so here is the electric potential for a single point charge, and also the electric potential for a group of point charges.